ready for our session? Today's lesson is about algebraic solutions of quadratic equations in one variable by completing the square. At the end of this session, you should be able to solve quadratic equations in one variable algebraically by completing the square. Kumusta pala ang buhay natin ngayon? Ano o sino ba ang nagpapakumpleto sa inyo? Pwedeng gadget, pwedeng pagkain, pwedeng module, pwedeng kaibigan o kaibigan. Kung ano man o sino man yan, ang mahalaga, masaya kayo. Pero huwag nating kakalimutan na ang Diyos ang tunay na nagpapakumpleto sa atin, kaya nakakasurvive tayo sa pandemic na to. Let's try first an activity that will warm you up entitled Complete Me. Complete with the correct letters to form mathematical term or word. The first one is P blank R blank E blank T. The answer is perfect. The second is blank Q blank A blank E. Correct. The term is square. The last one is T R I N O blank 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 blank. Good. The word is trinomial. Let's put the terms together. We form the phrase perfect square trinomial. Can you still recall how to find the last term of a perfect square trinomial, or also known as PST? That's the value of c in the quadratic expression ax squared plus bx plus c. We try finding the value of c when a equals 1 using the formula the square of half of b. In the first example, the given expression is x squared plus 10x plus blank. Identifying the values of a and b, we have 1 and 10 respectively. Use the formula and substitute the value of b by 10 and divide it by 2, we get 5. Then square it. The answer is 25. In the second example, the given expression is x squared minus 5x plus blank. The values of a and b here are 1 and negative 5. Using the formula c equals the square of half of b and substituting b by negative 5, since the number is not divisible by 2, we may express our answer in fraction form. So we have negative 5 halves. Then, square it, the value of c is 25 fourths. I know you can do the next activity. Apply the formula to find the value of c in the quadratic expression ax squared plus bx plus c, where a is equal to 1, to make it a perfect square trinomial. The activity 1 is entitled Make Me Perfect. In number 1, the last term is 9. How did we solve for the value of c? Since a equals 1, we simply divide the value of b by 2 and square the result. So, 6 divided by 2, the quotient is 3. Then, square 3, the answer is 9. In number 2, the value of b is negative 8. Divided by 2, the answer is negative 4. Then, square it, the result is 16. How about in number 3? What's the value of b? You're right. The value of b is 7. Notice that 7 is not divisible by 2. You may just express the answer in fraction form. That is 7 halves. Then, square the number. It will give us 49 fourths. In number 4, the value of b is negative 9. Divided by 2, the result is negative 9 halves. Then, square it, the answer is 81 fourths. For number 5, b equals 3 halves. Divided by 2, the quotient is 3 fourths. Then square it, the result is 9 over 16. Hope you got the items correctly. We all know that a perfect square trinomial can be expressed as a square of binomial, right? Let's recall how to do it. To express the given perfect square trinomial or PST as a square of binomial or SOB, get the square roots of the first and the last terms and separate the terms using the sign of the middle term. Then square the binomial. Consider the first example. The given PST is e squared plus 10e plus 25. The square root of e squared is e, and the square root of 25 is 5. Since the middle term is positive, we separate e and 5 by plus sign. Then, square the binomial. So we have the square of e plus 5. F squared minus 5f plus 25 fourths is another example of a perfect square trinomial. To express this as a square of binomial, extract the square roots of f squared and 25 fourths. The answers are f and 5 halves. Then, separate the square roots by minus sign since the middle term is negative and square the result. So the answer is the square of f minus 5. We now try the activity on expressing perfect square trinomial as a square of binomial. The next activity is entitled Make Me Some. Are you ready? What's the answer in number 1? Yes, you are correct. The answer is the square of m plus 3. How about number 2? Right. The answer is the square of n minus 4. In number 3, if your answer is the square of p plus 7 halves, you did it correctly. For number 4, the answer must be the square of r minus 9 halves. What about in number 5? Yes, indeed you are right in getting the answer, the square of u plus 3 fourths. Alright, I know you are now ready in today's session. We are through with 2 methods in solving quadratic equation in one variable. One method is by extracting the square roots, while the other method is by factoring. When do we use these 2 methods in solving quadratic equations? Extracting the square root is applied when one member is a perfect square, while factoring is used when the given is factorable. Consider the given quadratic equation x squared plus 6x minus 8 equals 0. Can we solve this by extracting the square roots? No, we can't, because the trinomial is not a perfect square. Can we use factoring? No, because the trinomial is not factorable. Let me introduce another method in solving quadratic equation in one variable by completing the square. To solve this by completing the square, you have to express the equation to the form x squared plus bx equals negative c. That means You will bring over negative a to the other side by applying addition property of equality, or known as APE. So the resulting equation is x squared plus 6x equals 8. Then, we complete the square on the left side by adding the square of 6 halves. That is equal to the square of 3, which yields to 9. 9 must also be added to the other side of this equation to maintain equality. Since the left member of the equation is a perfect square trinomial, we can express that as square of binomial, right? So, the binomial to be squared is x plus 3. Then, simplifying the right side, the sum is 17. Next is, we extract the square roots both sides, giving us the equation x plus 3 equals positive or negative the square root of 17. We are now ready to solve for the variable. One is x plus 4 taking positive square root of 17, while the other is x plus 3 taking negative square root of 17. Applying again addition property of equality, the values of x are negative 3 plus square root of 17 and negative 3 minus square root of 17. So, these are the steps in solving quadratic equation in one variable by completing the square. How sure are we that those values are the solutions to the given quadratic equation? We need to check if the equation is satisfied. To check, well, we always use the original equation. The original equation is the given equation. Let's replace x by negative 3 plus square root of 17. Notice that the equation is satisfied. How about the other value, which is negative 3 minus square root of 17? See, it is also satisfied. So, we say that negative 3 plus and minus square root of 17 are both solutions. Let me illustrate another example in solving quadratic equation in one variable by completing the square. The given quadratic equation is m squared minus 3m plus 2 equals 0. Although the given quadratic equation can be solved by factoring, let's try if we can also solve this by other method like completing the square. Transpose 2 to the other side. Transposing a term is actually applying addition property of equality. So the equation becomes m squared minus 3m equals negative 2. Complete the square on the left side. b is negative 3 divided by 2, so the quotient is negative 3 halves. Then, square negative 3 halves. The result is 9/4. That must be added to the other side of the equation. Express the left side of the equation as square of binomial. So we have the square of m minus 3 halves. The other side of the equation is equal to 1/4. We extract the square roots both sides. We obtain m minus 3 halves equals positive or negative 1/2. Solve for the values of m, applying APE. We get 2 and 1. Verifying whether the values are solutions, we check by substituting the values of m, which are 2 and 1. As noticed, the equation is satisfied by the values, so we say that they are the solutions to the given quadratic equation. Before we try a real-life application of today's lesson, we enumerate first the steps in solving quadratic equation in one variable algebraically by completing the square. First, we write the expression to the form x squared plus bx equals negative c. Second, complete the square on the left side by adding the square of half of b to both sides. Third, express the left side of the equation as a square of binomial. And the fourth, extract the square roots of both sides. Fifth, solve for the variable. Now, try to understand this real-life problem. Mrs. Henner wants the picture of her daughter be framed. Her conditions for the framing are: a border of uniform width should surround the picture. The area of the picture is equal to the area of the border. How wide should the border be? Let's illustrate the picture frame to help us visualize the problem. The blue rectangle is the picture, and the yellow rectangle is the frame. If we let W be the width of the border, and we add uniform width on the dimensions of the picture, then 5 plus 2W will be the width of the frame, and 7 plus 2W will be the length of it. How do we solve for the width of the border? To solve for the width of the border, we need the area of the frame, the area of the picture, and the area of the border. If we subtract the area of the picture from the area of the frame, that is the area of the border, right? The area of the frame is the product of 7 plus 2W and 5 plus 2W. The area of the picture is 35, and the area of the border is also 35. Forming the working equation, we multiply the length and the width of the frame, the quantity 7 plus 2W multiplied by the quantity 5 plus 2W, subtracted by 35, the area of the picture. The result is 35, the area of the border. Simplifying the binomials, we now have 35 plus 24W plus 4W squared minus 35 equals 35. Collecting like terms, it results to 4W squared plus 24W equals 35. Writing in standard form, it yields to 4W squared plus 24W minus 35 equals 0. How do we solve this quadratic equation? Can we apply extracting the square roots? No, since the left member is not a perfect square. How about factoring? No again, because the trinomial is not factorable. Can we do it by completing the square? We try solving this by completing the square. First, bring over the constant term to the other side of the equation. So we have 4W squared plus 24W equals 35. We complete the square on the left side of the equation by applying the formula C equals the square of half of B. But that only applies when A is 1. So we make the value of A equal to 1. That is only possible if we divide both sides by 4. The equation becomes W squared plus 6W equals 35/4. Completing the square on the left member, we add 9 to both sides. Then, express the left member as a square of binomial and add 35/4 and 9. It will yield to the square of W plus 3 equals 71/4. Extract the square root both sides. The answer is W plus 3 equals positive or negative the square root of 71 divided by 2. Solve for W by applying APE. The answer is W equals negative 3 plus and minus the square root of 71 over 2. Expressing it as a single fraction, the value of W is negative 6 plus and minus the square root of 71 all over 2. Performing the operations, one value of W is negative 6 plus the square root of 71 all over 2. That is approximately 1 21/100. While the other value is negative 6 minus the square root of 71 all over 2, that is approximately negative 7 21/100. Since there is no negative length or width, we accept the value 1 21/100. When the other value, which is negative 7 21/100, is rejected. We check if 6 plus the square root of 71 over 2 or 1 21/100 is a solution. Using the original equation, we replace W by negative 6 plus the square root of 71 all over 2. Performing the operations and simplifying, notice that we obtain an equality, meaning the equation is satisfied by the value of W. So we say that the width of the border is negative 6 plus the square root of 71 all over 2 inches, or approximately 1.21 inches as we read it conveniently. Hope the lesson is clear. If there are questions or clarifications about this topic, you may comment it down or send it to your respective math teacher. Now, let's check if you understand your lesson by doing the following assessment. After you're done, remember to submit the copy of your answers to your teacher. Thanks for watching. I hope that this learning content completes your day. Keep safe, everyone.